Hello and welcome to my channel. Having received the Peco/Kato Large England earlier this week, it's now time to attempt to DCC fit it. I should say I have done a small England with a DCC fit previously, so this won't be my first attempt, but I'll try and cover the pitfalls that I ran into while doing the small England. For this particular fit I will be using a Zimo MX616F harnessed decoder, and I'll be cutting the harness off to hardwire it. So, having removed the Large England from its box, there's a couple of things to be aware of. First of all, the tender is connected with pickups, so there is a connection through the drawbar. The other thing to be aware of, which I found out when working on the previous model, is that the cab is clip fitted to the boiler, and in turn the boiler assembly is friction fitted to the chassis, but the whistles and whistle piping are also clip fitted. So if you accidentally detach the cab, you may spring the pipework that the whistles are attached to, and the whistles may flick off. If you do lose a whistle, they are so small you probably won't find them again, so we'll need to be talking to Peco for a replacement. So I'm actually what I'm going to do before I attempt any dismantling is I'm going to put a little card layer, just blue tacked, between the roof and the front of the loco to try and stop the cab from detaching and the whistles from going anywhere. It's just an important point. I'll also detach the tender. So this shows the underside of the loco and the connection to the tender, the drawbar. I'm just going to tilt it upright and detach it. It should firmly pull apart. So gripping both sides equally and just doing a gentle pull, and there you see, that's how easy it is to detach the tender. So the tender can now be put to one side, because you won't need that while fitting the DCC decoder. So as previously mentioned, I've put a piece of card just tacked between the chimney and the top of the cab roof to stop the cab from detaching from the boiler and from the whistles, more importantly, from springing off, because they will disappear if they spring off. So I'm just going to try and demonstrate removing the chassis. So what you're trying to do is grip bits of the motor assembly that aren't part of the chassis and slowly ease it out. It is only a friction fit, but it is quite tricky to get a grip on something that isn't part of the upper thing, and you don't want to bend any of the rodding between the wheels. So you basically keep rocking until it gets free. Maybe turn it around a few times and ease from different ends. There we go. I've just had a little breakthrough there. It's moved, and there we go. One clear motor separated from the body, which is still intact. I'm going to put the body to one side and just get a better look at the motor now we've got it out, the motor assembly. As you can see, there's a worm gear with a flywheel at one end, and then I'm going to get my pick just to illustrate. You've got, now this is the tricky bit, you've got the wires coming down from the motor on this end. They go to these metal strips, which are just about visible in this channel, and then on the other side you've got the same. You've got another wire here going to a strip in this channel. So that's the bit you're trying to break the circuit on, the connection from the metal strip to the motor to put your decoder in, and this is the space you are working in. But so I'm going to hardwire because the space is quite tight. But you're looking for a decoder that fits in this gap here and doesn't foul too far forwards, and that you can drop the wires down to the contacts on the ends. So I'm going to try and take some better still shots that show where those contacts are, and I'll splice them into the video. So I couldn't find my micrometer, so I've used a ruler for this. As you can see, there's probably just under 9 mm of width where the decoder will sit, just above the barrel of the motor itself. And as we switch to the side view, this is a bit misleading because the bodywork itself fouls on some of that, so you've probably only got about 10 mm before you have to worry about the bodywork coming down over the top. So it isn't a full 20mm that you have to work with. This just gives a slightly clearer view of how the strip is fitted into the channel, and it's the same on the other side. And I've just added some arrows that indicate where the bumps are that secure the copper strip. There's two pushing upwards and one pushing downwards inside the channel. One thing I usually do before taking the body off, but certainly always do before interrupting any wiring when fitting DCC, is do a quick test on DC. So I've just got this on a rolling road. I'm just going to turn up the speed, and you'll see this is, you know, more or less straight out of the box, this terms of running, but you know, it's definitely a working motor. So I do know that the loco itself was operational before I actually cut into any wiring. I'm just going to reverse the direction and go the other way. So there we go, working loco, reasonably stable as well, considering rolling roads often show any kind of imbalance. So pretty good. Basically the wiring from the motor goes to these copper strips which I mentioned earlier. The copper strips actually then in effect electrically connect to the chassis, so it's sort of a split chassis design. The copper strips themselves, however, can be sprung out, which does make the soldering somewhat easier to do later. I'll just see if I can get it out. There we go. You just ease from the front, and you see we've now got a sprung copper strip on the red wire side, has been eased out, which basically means you can unsolder that wire now. But what the strips clip in between is a sequence of ridges in the channel, two pointing upwards and one pointing down. So some people actually gave up on doing when fitting them back in and just blue tacked them in hard. You can actually, once you realise that it's an up and down pair of lugs, you can actually spring it back in when it comes to refitting. So I'm just going to spin it around and switch to left-handed mode briefly. I'm going to pop the one out on the other side as well. So just trying to ease the screwdriver blade underneath the front edge of the clip, and there you go. You see it comes out quite easily. So whilst you initially think, oh my god, I'm not going to be able to solder on that, once you realise that the strips can be popped clear, leaving you, and you can unsolder at the point where the clips, the wires meet the clips. You're not actually shortening the wires at all in any way, shape or form, which is helpful. And it gives you a nice place. You're going to be putting the decoder between the wires and the clips, sitting the decoder finally up here. So you do want to cut the wire lengths on the decoder so some kind of appropriate length that it can sit here. So I've now extracted the decoder from the packaging just to show where it will sit. What I'm going to do is I'm going to shorten the decoder wires down quite hard. So the motor wires, so the right and left motor wires, orange and grey I think it is, they're going to be slightly shorter than the rail wires, because the rail wires have to go down to the ends of those copper strips, whereas the motor wires are going to be attached to the existing wires on the motor, giving a bit of length. So I'm basically going to cut it, you know, cut the whole assembly maybe about, you know, there-ish. I'm then going to shorten the motor left and motor right wires a little bit further. I'm going to remove the lighting wires that I'm not intending to use. Normally I'd leave those on just in case of future requirements, but for this little model I'm never going to be adding lighting or any extra functions, so there's no need to leave the wires on. So I'm actually going to cut all the unwanted wires short, just to get them out the way. I'm not showing the desoldering and soldering process in full, but what I've got here is an interim stage where I've completed the desoldering and the soldering. I've got some shrink wrap ready to slide back over the solder joints of the motor wires, so red to orange off the motor, black to grey. I've got the two rail wires, red and black, attached to the silver strips, and they need reseating back in their channels and pushed past the little bumps that secure them. So we're getting there basically. The decoder chip itself will then fold over into this area. It will need a little bit of insulation because you've got metal each side and metal underneath. So soldering complete. and it's sitting on a rolling road waiting for some DCC testing. So it's still on ID3 at the moment. I'm just going to turn up the speed, and we'll see. I haven't turned it very far yet, you know, maybe just a fraction, so slow speed pretty good. And then climbing, and I just slow it back down and make sure it works in the opposite direction. And there we go. But let's say the basic testing done. We've just got to put it back together now. And now reassembled the Large England sitting on the rolling road and the Small England that I did some time ago in terms of a similar conversion. I'm just going to start the Large England moving again. One thing I did have to do was, compared with this shot where I showed the chip and wiring in place, I did have to route the wires very slightly down the side of the boiler because there's a moulding on the underside of the bodywork that was fouling, and it needed a very slight adjustment, and I trimmed the card very slightly that was used as an insulator as well. But other than that, there were no real problems fitting the body back over the decoder, and as you can see, it's an operating loco. So job done basically. I'm just going to reverse the direction again and we'll get it going the other way. Yeah, job done. So hope this proves useful to someone.